Hello everyone. So welcome to the marking scheme of Form 1 worksheet, worksheet number 4 or week number 4. And my name is Mr. Zabron Ernest. I'll be taking you through this worksheet. All right, so here we go. We have this question here. Question number 1. Question number 1 says that Hassan asks some children in his school to name their favorite sport. He shows his results on a pictogram. So this is a representation of information using pictures. And this is what we basically call it as a pictogram. So we have football. Football has 1, 2, 3, 4, 5, 6, 7 pictures. Netball has 2.5 pictures. Basketball, cricket, and volleyball, and so on. So let us see the question here. For pictogram, as we all know that a pictogram is a representation of information using pictures. So we have to include a key to define each picture represents how much information. So the key given here is incomplete, so we need to complete that key. So part A, 50 children choose cricket as their favorite sport. Use this information to complete the key on the pictogram. Okay, so 50 children choose cricket, okay? So here we have cricket has been chosen by 50 children. But if you check closely, for cricket, we have 1, 2, 3, 4, 5 pictures. So 5 pictures, 5 pictures is there to represent 50 children. So we have to know one picture will represent how many children. So in other words, you have to cross multiply. So it will be 1 times 50, you divide by 50. 1 times 50 divided by 5. And this will be giving you somewhere around, 1 times 50 is 50, divided by 5, it will be giving you somewhere around 10. So each picture will mean 10 children. So the key is completed. Part B, how many more children choose football than basketball? How many more children choose football than basketball? So here we have to compare the number of children selecting or choosing football versus the number of children who choose basketball. So since we already know that each picture equals to 10, each picture here equals to 10 children. So it means that for football, we are going to have 1, 2, 3, 4, 5, 6, 7. So for football, we are going to have 7 times 10. So for football, we are going to have 7 times 10, and this gives you 70 children. And for basketball, we have 1, 2, 3 full pictures. We have 3 full pictures, so we do 3 times 10 equals to 30 children. But then we have this picture which is a half of 10, because each picture equals to 10 children. Now, half picture will mean half of 10, and that will be giving you 5 children. So half picture will stand for 5 children. So we have to take 30, add 5, we get 35 children. So to answer this question here, which says how many more children choose football than basketball, you'll be taking a difference between 70 and 35. So what we do basically is you take 70 minus 35. The answer you get will also be 35. So the answer is how many more children choose football than basketball? So 35 children choose 35 more children choose football than basketball. So 35 more children choose football than basketball. So this is your final answer, 35. What fraction of the children choose cricket? This is part C. What fraction of children choose cricket? Okay, for cricket, we already know that there are 50 children who select or who choose 50 children who choose cricket. Now, what fraction of the children? So we have to get what fraction of the children. So we have to count how many children are there in total. But mind you, half a picture represents 5 children. So we have, for football, we have 1, 2, 3, 4, 5, 6, 7. There are 7 pictures, but each picture is 10. So we have 70 children for football. For netball, we are going to have, there are 2 full pictures, so multiplied by 10, plus half a picture, which means 5 children. And this gives you 2 times 10 is 20, plus 5 is 25. Keep going for basketball, we have 1, 2, 3 full pictures multiplied by 10, then add 1 half picture, which stands for 5 children. So in total, we're going to have 30 plus 5, we're going to have 35. For cricket, it's known that 1, 2, 3, 4, 5 pictures multiplied by 10. For cricket, it was given before that there are 50 children who choose cricket is their favorite sport. For volleyball, we have 2 times 10, and that equals to 20 children who select volleyball as their favorite sport. So now we have to calculate the total number of children here. Total number of children here will be 20 plus 50, that is 70, plus 70, 140, 140 plus, this is 60, so 200, somewhere around there. So 200, let me check. 25 plus 35, this is 60, 80, 150, 200, okay, 200. So total number of children is 200. Now, what fraction of the children choose cricket? That means you take 50 for cricket, divide by the total number of children, which is 200. And then upon simplifying, you're going to get somewhere around 1/4. This is the fraction of children who choose cricket. Okay, so by 5, 1, by 5, 4. The fraction of children, the fraction of the children who choose cricket is 1/4. All right, I hope that helps. Let us keep going. Okay, we have this question number 2. Now this question number 2 says, Bless collects information to investigate this statement. We are given this statement which says, boys in my school, the school of Bless, play more sport each week than girls. So this is the statement which can either be true or can be false. And this statement, which can either be true or false, is known as the hypothesis. So the hypothesis is the statement which has to be investigated. All right, so Bless is collecting information to investigate this hypothesis or this investigation, this statement. Now the question is, if Bless has to investigate whether boys in her school play more sport each week than girls, so Bless has prepared this kind of questionnaire. Now tick the 2 items that are most relevant to her investigation. Now, Bless wants to know whether boys in her school play more sport each week than girls. So we have to tick the 2 items from here that will appear to be most relevant to her investigation. Now, age of a student. You are trying to investigate if boys play more sport than girls, and then you ask age of a student. Is that question or is that item relevant? This is not relevant. Gender, yes, because you're talking about among boys and girls. So you have to know the gender of the student. So this is very important. Time spent, yes, that is very important because you are trying to investigate whether boys in that school play more sport each week than girls. So you have to find out how much time is spent by boys to play sport compared with the girls. Favorite sport, you don't have to know their favorite sport because the idea is to find out whether boys in the school play more sport each week than girls. So that means to tick, that means you'll be ticking only these 2, gender and time spent, okay? I hope that is clear. Now, Bless collects data from 10 of her friends. Remember, Bless is collecting information to investigate the statement which says boys in her school play more sport each week than girls. Now, surprisingly, if Bless collects data from 10 of her friends, we say that that information that will be collected from 10 of her friends will not be reliable, will not be giving reliable results, because basing on the following reason. Explain why she may not get reliable results for her data. So reason is that the sample size of only 10 students is too small to get reliable. It's too small to get reliable results. So the sample is too small because Bless is trying to investigate whether boys in her school, in her entire school. So there is no way if you are investigating something which is about the school and then you ask only 10 students. And also these 10 students are again her friends. So there may be some kind of biasness. There may be some kind of biasness in that data. All right, question number 3, Chen investigates how people in his town will vote in an election. Here are 3 methods he uses to collect data. Tick the correct box to show whether each method collects primary or secondary data. All right, so you have to know the difference between primary and secondary data. Basically, we say primary data is data that you collect yourself. So this primary data is the data which you collect. You collect yourself. You have to collect yourself. See that? But now, secondary data is the data which you don't collect yourself. It's already collected by somebody. So primary data is the data which you collect yourself, whereas secondary data is the type of data that somebody else collects. So this is collected by yourself, but here is collected by someone else. It's collected by someone else. You see that? That's the only difference. All right, so secondary data is basically obtained from the textbooks, and also is obtained from the internet or the library, because all secondary data is the type of data that somebody else has already collected, or can get it from the encyclopedia. See that? All right, and so forth and so forth. Now, primary data, you collect information by yourself, and this can be done by giving a short interview to people, or prepare a questionnaire. That is the ways, those are the methods which you can use to collect primary data, the data which you collect yourself. So interview, questionnaire, or perform an experiment and correct the data yourself. Perform the experiment and perform the data yourself. Or perform an observation. For example, you want to know the type of cars driven in Dar es Salaam. So you will be doing an observation to see the models of the cars driven mostly in Dar es Salaam. Is it Toyota Harrier, or is it Toyota IST? Is it Hummer? Is it Range Rovers, and so on and so on. So you have to do observation. By so doing, you'll be collecting primary data, because that is the data which you will be collecting yourself. Right, so let us do matching. If you go and ask the parents, okay, Chen investigates how people in his town will vote in an election. Here are the three methods he uses to collect data. Tick the collect box to show whether each method collects primary or secondary data. Ask the parents of his friends. If you are asking people, that means that is some sort of interview. So you are giving short interview to those people, and therefore, if you ask the people or asking the parents of his friends, that type of data collected is tick. We have to tick. So is the primary data. Look for survey results on the internet. Like as I said, something from the internet is something which you have not collected by yourself. Has been collected by somebody. So that is secondary data. Go to the library to read the books, some reference books. Those data in the book, on the textbook, are not the ones which you have collected. They've been collected by somebody. In that case, the information that we collect from the library is being collected by somebody else, and therefore that is secondary data. All right, I hope that is clear. Let me go to next part. The next part is this part here. Let me try to zoom out so that you can see everything. All right. So we are supposed to draw a line from each set of data to its description. One is done for you. Okay. We have set of data here. We have shoe size, we have body temperature, we have number of pets people have, we have money in a purse, we have height of students, and on the other side, we have two words, we have two vocabularies here. We have discrete and we have continuous. Possibly, let us see what they mean. Let us see what distinct mean. This discrete data, this is the type of data that is involving, it involves counting. It involves counting. So any sort of data that you obtain after counting, that type of data is known as distinct data. Now, when it comes to continuous data, now we say continuous data is the type of data collected from measurements. So continuous data involves measurement. You have to measure, you have to do measurement for you to get the so-called continuous data. This data is something which involves counting. For example, you want to know the number of people in your family. If they ask you how many people are there in your family, you don't have to go and do measurements. You simply go and count, and such number is fixed. If they are 10, they are 10. You can't say they are 10 3/4. No, you don't have to say so, because the number of people in any family is something fixed and something that can be answered by simply counting. Right? So if they ask you, for example, your height, what is your height, or what is your mass, the weight, and so on and so on, or your body temperature, all those will need measurements, and therefore that will mark what we call continuous data. Now, after that small introduction, let us now go and do some matching. Shoe size. Now, this is where most people confuse. We do not measure shoe size. We don't measure shoe size. Shoe size is already there. Shoe size is already fixed. If you go to the shop selling shoes and you are requesting to buy a shoe, a pair of shoes, they will ask you what is your number, and your number is fixed. It can be 35, it can be 40, it can be 50, it can be 36. It depends on your foot length. Now, this is where most people confuse. When we say shoe size, we do not mean foot length. You see that? So two things different. Foot length, we need to do measurement. What is the length of your foot? You have to measure. But shoe size is something fixed. Shoe size, you don't have, they are already there in the shop, so you just mention the number, okay? Shoe size and foot length, these are two different things. So for shoe size, they are already fixed and they are already counted, and therefore shoe size is distinct data. But if it was foot length, if this was foot length, then foot length should be continuous data, because foot length, we need to do measurement. But otherwise, unfortunately, it is shoe size and not foot length, okay? So I hope that is understood. Body temperature, like as I said earlier, body temperature is not fixed. It has to be measured. If you go to hospital, they cannot simply try to predict what is your body temperature. What they have to do is to do measurement. So in that case, body temperature is continuous data, because continuous data, we need to do measurements. Number of pets people have, that you need to just count. How many pets you have, how many pets people have, you need to count. Money in the purse, money in the wallet, this is simply distinct. You need to count how much money is there in your wallet or in your purse. So that is distinct, and it was given as an example. Height of students, you have to do measurements in order for you to in order for you to recognize the height of the students you have in your class, for example. Hope that is clear. Now let us go to the next part, which is question number 5. Question number 5, let me try to zoom out so that we can see everything. All right, so here we go. Mrs. Green, right? So we are given this question here. Mrs. Green counts the number of children who walk to school. Here are the results of 20 days. Okay, these are the results of 20 days. Complete the frequency table. Now, as you all know that a frequency table is a table which contains 3 columns. A frequency table is any table which has 3 columns. The first column stands for the data itself. Now, can be given in the form of intervals like this, or can be given as a listed data or as a raw data. Raw data means the type of data which is not given in the form of intervals. It's just raw, it's just listed data. Okay, so the first column will show the data itself, and the second column will show the tally. The tally, I'll be showing you what tally means. And also the last column stands for the frequency. The number of times a number appears in a list. Okay, I hope that is clear. Now, how do we complete this frequency table? It is easy. We have to check all the numbers which are from 1 to 10, include 1, include 10 in the list. So all numbers between 1 to 10, I can see that there is a 7. So I do tally that. So tally is some sort of cancellation that you do in these numbers given. So 1 to 10, there is 7. 1 to 10, there is 6. From 1 to 10, there is 9. From 1 to 10, do we have another 1 to 10? No. So 1, 2, 3 will be our frequency. That means we have only 3 numbers which fall in this interval 1 to 10. 11 to 20, 11 to 20, yes, we have that. 11 to 20, yes, there is 11 itself, so you count it there. 11 to 20, yes, we have that. 11 to 20, yes, we have that. 11 to 20, now listen, there is here 1, 2, 3, 4. So the 5th one has to cross over like that. So 11 to 20, we have 5 numbers. 21 to 30, 21 to 30, we have that number there. 21 to 30, we have that number there. 21 to 30, we have that number there. Also, we have this number. 21 to 30, we have that number there. So we have to close that way. And then we have 21 to 30, we have 21 itself. So we cancel it there. 21 to 30, we have 22. 21 to 30, 21 to 30, we have this number here. 21 to 30, we have that number there. So you have 1, 2, 3, 4. This bundle is 5, so 5 plus 4 makes 9. Guess what? 31 to 40 will be the remaining others. 31 to 40, 31 to 40, 31 to 40. Nope. Oh, 31 to 40, there is that. Okay, any other number which is not cancelled? So you can see everything is cancelled. So here you write 3. Now, how do we quickly check if our table is correct? How do we quickly check if our table is correct? Is simply draw out a total. Draw out a total And that will be equal to 3 plus 3 is 6, plus 5 is 11, plus 9 is 20. Now this total 20 should be equal to when you count the numbers individually. So 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 is 20. So you can see that our frequency table is matching exactly with the number of, with when you count these numbers individually. Okay, write down the model class. Okay, write down the model class. Now, you can't answer this question unless you know the definition for the model class. Now, we say the model class is the interval. Model class is the interval. So when selecting the model class, I'll be looking from these intervals here, okay? So model class is the interval. So I'll be looking from here, from this set of intervals, okay? So model class is the interval which has the highest frequency. You see, the highest frequency. Now, model class, remember, model class is not the frequency. Model class is not the frequency. Model class is the interval, which has the highest frequency. Okay, so model class is the interval. Let me go back here. Can you see these intervals? How many intervals are there? 1 to 10, 1, 2, 3, 4. There are 4 intervals. Now, what is the frequency of this interval 1 to 10? The frequency is 3. What is the frequency of 11 to 20? The frequency is 5. What is the frequency of this interval 21 to 30? The frequency is 9. And what is the frequency of 31 to 40? The frequency is 3. Now, which interval out of all these appears to have the highest frequency? The highest frequency is 9. Now, don't say model class is 9. No, don't say 9. Mention the interval which has the highest frequency. That will be your model class. So in this case, model class is the interval 21 to 30. Let me check it properly. Yes, 21 to 30 is the model class. How did I know? Because it has the highest frequency. I hope that is clear. So model class is 21 to 30. So here, you write model class is 21 to 30. All right, let me push on. Okay. Let's go to this question. This question is talking about 7 children. Let me see if I skipped anything here. I hope all is in order. Yes, all is in order. Okay, let me go to this question. Can I try to zoom in? Let me see. Wow, so this can look like this, right? But it looks so huge. I get 150. All right, there we go. So we have this question here. 7 children measure their pass rates before and after exercising. We have before exercising, the pass rates were 72 per minute, 72 beats per minute, 79 beats per minute, 84, 69, 74, 80, 75. After exercising, you can see that the number of beats per minute has risen, has a little bit increased. Okay, they look huge compared with the the ones before exercising. So we have 116 beats per minute, 120, 130, and so on and so on. Okay. Now, let us see the questions. Let us see the question. Complete the table by finding the median pass rate before exercising. The median. So you can see there is a terminology here, median. So let me define what does median mean. Okay, let me start defining what does a median mean. Median, the way how it sounds, median is the middle value, is the middle number. But is the middle number when all the given numbers are arranged in order of size, meaning meaning can be from smallest to largest. So you have to arrange the given numbers from smallest to largest, and then you pick which number is at the middle. All right. Now let us see these numbers. They said complete the table by finding the median pass rate before exercising. The median before exercising is missing. So what I simply do is to take these numbers before exercising and arrange them from smallest to largest. Now the smallest of all here is 69, 69 is done. Then the next will be, after 69, will be 72. Then the next of 72 will be 74. Then after 74 will be 75. Then after 75, we'll shoot to 79. Then after 79, we'll be going to 80. After 80, we'll be heading to 84. Okay? So make sure that all the numbers are arranged from the smallest to the largest. Okay, now from here, can you tell me which one is at the middle? You can pause the video and try to look for the number in the middle of this distribution or of this list. All right, but here let us continue. The number which is at the middle, we normally cancel one number from the left and cancel the other number and cancel the other number from the right hand side, leaving the middle number exposed. So keep canceling from left, keep canceling from right. We'll be getting this number being exposed at the middle, and there is your median. So your median will be 75. See how easy it is? So the median will be 75. You see that? So far, so good. Now, the question can be, what if in the middle, after canceling one number from the right, one number from the left, one number from the right, one number from the right, one number from the left, after canceling those numbers, what if it happens that you remain with two numbers in the middle? Now, if it happens that you remain with two numbers in the middle, what we do, we add those numbers, and then divide by 2. For instance, let us say we had these numbers. Suppose we don't have these numbers here. Suppose these numbers are not there. So then, if these numbers are there, if these numbers are not there, then what do we have? We have 72, we have 79, we have 84, we have 69, we have 74, we have 80. Now suppose I'm looking for the median of these numbers here. I have to do the same thing, arrange these numbers from the smallest to the largest. So in this case, the smallest will remain 69. The next smallest, 69, next will be 69, will be 72. Next will be 72, the next will be 74. 74, the next will be 79. 79, then the next after 79 will be 80. 80, and then the last one will be 84. See that? Now, let us see what will the median be. Okay, cancel one number from the left, cancel another number from the right, cancel one number from the left, cancel one number from the right. If you keep canceling, then nothing will remain. Nothing will remain. So that means you must remain with two numbers. Now, if it happens that you have left with two numbers, remember what I said? For the median, if you are left with two numbers, for the median, you will take 74, which is this number, plus 79. The answer you get, you will have to divide by 2. So you can do that calculation, and that will be your median. So 74 plus 79, you get that answer, then you divide by 2, that will be your median. But for this case, unfortunately, we had only one number in the middle, and that is okay. Sorry for the interruption that happened, but let us proceed. I was interrupted somewhere. Okay, now let us proceed. Now, we already know that the median before exercise is 75 beats per minute. And next time, I'll be coming to talk about the range. But since the range are the same, then for now, let me ignore the concept of range, because unfortunately the ranges are the same, but in future, I'll be coming back to you to explain what is the significance of a range when you are to compare the two distributions or the two sets of data. But for now, the median, before exercise we got 75, and the median after exercise was given is 120. Now the question is, can you compare the pass rates before and after exercising? Now what I can see is that the median before the exercise is smaller than the median after the exercise. Now what does it imply? It means that the pass rates after exercising are higher, the pass rates after exercising are higher than the pass rates before. See, are higher than the pass rates before. And this is how quickly you can make comparison. You see? So until next time, let us stop here. Bye-bye for now. I'll be back to you in a near future. All right, stay tuned. Remember to subscribe and hit the notification bell button, and that will mean a lot when it comes to my channel. Bye-bye for now. All right, bye.